So, good evening to everyone. Today topic is acid rain in meteorological data, meteorology unit. Okay. So acid rain is the part of the meteorology, right? So now, what is acid rain? So acid rain. So acid rain term. So it was coined in year of 1852. 1852 by Scottish chemist, right? Robert Angus Smith. So he is a Scottish chemist in the year of 1852. So he was coined. So according to the Royal Society of Chemistry, so which calls him the father of acid rain, he said, so he decided, Smith decided on the ton while examining rainwater chemistry near industrial cities in England and Scotland. So he wrote about his findings in 1872. 1872 in the book so air and rain, the beginnings of a chemical climatology, right? So he wrote this book. So in 1950s, scientists in the United States, they have started studying the phenomena, and in the 1960s, 1960s and early 1970s, the acid rain became recognized as a regional environmental issue. So that affected Western Europe and Eastern North America. Western Europe and Eastern North America. Right? So now acid rain. So what is acid rain? Acid rain is also termed as acid deposition or acid precipitation. So it is a type of rain in which deposition of acid takes place along with rainwater. So the acid rain or acid deposition is a broad term that includes any form of precipitation with acidic components such as sulfur, right? Sulfuric or nitric acid. So that fall to the nitric acid. So it's fall to the ground from the atmosphere in wet or dry forms. So this can include rain, snow, this fog, hail, and dust, or even dust that is uh, having acid components. So atmospheric pollutants like oxides of nitrogen and sulfur, sulfur oxides. So it reacts with rainwater and leads to the formation of acids like nitric or sulfuric acid and fall with the rain. So that is called acid rain. So what is acid rain? The atmosphere for pollutants, oxides of nitrogen and sulfur. So those are react with rainwater. So it leads to the formation of acids. So like nitrogen is nitric oxide, and sulfur is sulfuric acid. So and it falls with the rain. So it's called acid rain, right? It's called acid rain. So main thing is sulfuric acid and nitric acid. So these are the main important. Now, so the acid rain is not a new thing, right? So it was first coined in where? First coined in Manchester, England, over a century ago, right? So now, so it is believed that oxidation of sulfur dioxide, so that is much slower than that of nitrogen oxide. So that sulfur dioxide may remain airborne for how much? 3 to 4 days. It compared with nitrogen oxides, which may persist for only half a day. Only half a day. So the consequences of this phenomena is that acid rain derived from this sulfur dioxide is transported much further than nitrogen oxides. So in Europe, the cause of acid rain is largely sulfur oxides followed by nitrogen oxides. Okay, in Europe only. And sequeira, Sequeira, sequeira in the year of 1987, that is recorded trace to slight weighted average free acid levels. It means free acid levels means pH is 5.8 to 4.7. So south of 47 degrees north, south of 47 degrees north. So that is except in northern Italy. So moderate or high acid contains, those are 4.5 to 4.2. These are high acid contents were recorded in north of this latitude. Okay. So now causes. What are the causes of acid rain? So acid rain is basically caused by two types. First one is natural causes and second one is man-made causes. So in natural causes, it can be caused due to, you see here, lightning, volcanic eruption, and biological process, and also wildfires. So these are the natural causes of acid rain. So now, one by one, so we're going to one by one, like first one is sorry, these are the natural causes and these are the man-made causes. So what are the industries and coal-based thermal power plants and exhaust from automobiles and burning of fossil fuels and domestic fires and also smelting of metals. So these are the total man-made causes and these are natural causes, right? So in this, what is lightning? Okay, right. So lightning, so in this, the enormous energy in lightning, it generates nitrogen ions from the which place? Atmospheric nitrogen, which is from acids with the combination of water vapors and it leads to acid rain. Okay. And lightning strikes also naturally produce nitric oxides so that react with water molecules via electrical activity to produce nitric acid. So thereby forming acid rain. Okay. So this is the lightning. And volcanic eruption. Volcanic eruption means, so this is natural cause, right? Natural cause because this is something which happens in nature which is not in our control, right? So whenever any volcanic erupt, a blast of gases conserve from within the surface of the air, so which contains of oxides of nitrogen and sulfur and also uh, carbon again. Right? So the volcanoes emit acid-producing gases, that is to create higher than normal amounts of acid rain or any other form of precipitation such as fog and snow. So those to an extent of affecting vegetation cover and health of residents within the surroundings. And third one is biological process. So the biological process so that occur on the land in a water bodies also generate acid producing gases to the atmosphere. And last one is wildfires. So wildfires, so uncontrolled forest fires, right? Uncontrolled forest fires also release acid producing gases. Okay. So decaying vegetation, wildfires and biological process within the environment also generate acid rain forming gases, right? So dimethyl sulfide. Dimethyl sulfide is a typical example. So you can say this dimethyl sulfide and this, this is the a major biological contributor to sulfur containing elements into the atmosphere, right? So now, man-made causes are anthropogenic causes. It's called anthropogenic causes also. So those are industries, right? Industries. So industries means human activities, right? Human activities leading to chemical gas emissions such as sulfur and nitrogen. So those are the primary contributors to acid rain. And coal-based thermal power plants. So again, emit in this sulfur and nitrogen oxides also. And exhaust from automobiles. This is also very important. So this is again something which is related to fossil fuels, right? This fossil fuels. Well, all know so that most of all vehicles such as cars, trucks, buses. So these are either petroleum or diesel vehicles. So both these are fossil fuels. Whenever we are using these fuels in the vehicles, we are giving out emissions. So which contain oxides of sulfur and oxides of nitrogen. So which contribute to acid rain, right? And burning of fossil fuels. So this is the first major reason which causes acid rain. So because all fossil fuels, whether it is coal, right? Coal or petroleum. Coal or petroleum and other products also. So they contain sulfur and nitrogen along with carbon. So whenever under growth of this process of conversion, they release oxides of carbon and oxides of nitrogen as well as sulfur in the atmosphere. So these three main gases, which one? Nitrogen oxides, carbon oxides, and sulfur oxides. So these three main gases which are responsible for causing of acid rain. Okay. And next one is domestic fires. So domestic fires release smoke that contains CO2, right? CO2, carbon dioxide. Domestic fires. Domestic means households, anything. Okay. And last one is smelting of metal, right? Smelting of metal ores. So in this process, the release of acid producing gases such as carbon monoxide and carbon dioxide takes place into the atmosphere. So basically, the three main gases that is responsible for causing of acid rain. So what are the three main gases? Those are oxides of carbon and oxides of nitrogen and oxides of sulfur, right? So those are the three main causative agents or the causative gases which result in acid rain. So these gases culprits we can say which cause acid rain in our environment, right? So now we're going to how to form acid rain or forms of acid rain. So there are two forms in which acid deposition occurs. So first one is wet deposition of acid rain and second one is dry deposition of acid rain. Okay. So now we're going to one by one. What is wet deposition of acid rain? So first you see this picture. Okay. So you see here this wet deposition. Okay. Wet deposition. So in wet deposition, moving air, right? Moving air blows the acids present in the atmosphere to the areas where the weather is wet. Where the weather is wet. Thereafter, acids fall to the ground. Okay. In the form of this one, rain. And sleet or fog, snow or mist, right? So it removes acid from the atmosphere and deposits them on the earth surface. Okay, earth surface. So what are the effects of wet deposition of acids? So these acids after falling on the ground here affects the large number of plants. You see here, large number of plants and also animals and aquatic life, right? So these are the most affected things. So the water from drain flows into rivers and canals, so which is them mixed up with seawater and therefore thereby affecting marine habitats also. Okay, these are the most effects of wet deposition of acids. So this is the picture you see here. These are the main pollutants, SO2, NO2 and NH. So these in dry deposition. So this is wet deposition. So in wet deposition, SO4, NO3, NH4. Same. Okay. So in dry deposition, what is dry deposition of acids? So in dry deposition, moving air blows the acids present in the atmosphere to the areas where the weather is dry. So the acidic pollutants slip into dust or smoke and fall to the ground as dry particles. Right? Dry particles here. So what are the effects of dry deposition of acids? So the fallen acid particles get stick to the ground here, okay? And other surfaces such as car and also houses and something, any trees and buildings, right? So these particles affect the soil fertility and make it unsuitable for growing crops also. Unsuitable for growing crops. So almost 50%, right? 50% of the acidic pollutants in the atmosphere fall back through dry deposition only, right? 50% acidic pollutants. So further, these acidic pollutants can also be washed away from the earth surface by which one? Rainstorms, right? Rainstorms. Yeah.
Okay, sure.
So you see this picture, wet and dry deposition also. This is also another one. You see here, sulfur dioxide incorporated into water droplets or water vapor in clouds. So this is called acid rain.
Okay, sure. Okay, lanjut. Malam-malam tak cuma tengah.
So you see here, wet deposition. So what we most frequently associate with acid rain is wet deposition, right? So the sulfuric and nitric acids that have generated into the atmosphere combine which one? With rain, snow, fog, and hails. So as they fall to the ground, right? So numerous plants and animals. So those are impacted as this acidic water permeates the ground and runs over it. So the degree of the impacts is insufficient by a number of variables such as the degree of acidity of the water, the chemistry and capacity of the soils to function as a buffer and the kinds of fish, trees and other living things. So that depend on the water. And gases and particles, those are removed from the atmosphere by which one? Precipitation. Through two ways, right? Two ways. So those are rain out and wash out. So rain out means which is when particles are incorporated into cloud drops so that fall to the ground. And next one is wash out. What is wash out? So in washout, which happens when materials beneath a cloud are dragged down by rain or snow that falls. So this is the wet deposition. And next one is dry deposition. In dry deposition, the acid compounds are deposited through dry deposition in locations with dry weather. So the gases and acidic particles may instantly settle to surface bodies and vegetation or buildings, right? Surfaces and means water bodies, vegetation or buildings, or they may react with being transported through the atmosphere, that is to produce larger particles that may be dangerous to our health. So the rainstorms runoff can remove dry depositions of gases and particles from these surfaces. Okay. Which surfaces? This one, water bodies, vegetation and buildings. So the mixture that results is more acidic because of this runoff water. So the dry deposition result in return of around half of the atmosphere's acidity to the our planet. So the quantity of acidity in the atmosphere that falls as dry deposition to the soil depends on how much rain falls in a given that particular area. So for instance, compared to a location that receives several inches of rain each year, and desert areas, they have a larger ratio of dry to wet deposition. So these are the wet and dry deposition. Now, how to form acid rain? You see here, when those gases come up into the atmosphere and when it rains, they combine with rainwater, right? So what happens is that the carbon dioxide, you see here, carbon dioxide is present in excess in the atmosphere and it combines with water, right? With water that is present in the atmosphere. It forms what is this? Carbonic acid, H2CO3, carbonic acid, right? When carbon dioxide reacts with the water, it's formed carbonic acid, right? This is the formation in carbonic acid. And next one is oxides of sulfur. Oxides of sulfur, those are present in the atmosphere. They again combined the rainwater and fall down. And what is this? This one, what is this? Sulfuric acid or sulfurous acid. H2SO3 or H2SO4. H2SO4. Sulfuric acid or sulfurous acid. H2SO4 and H2SO3. So now similarly, if oxides of nitrogen are present in the atmosphere, then again they combined with rainwater. Combined with rainwater and the fall down as, what is this? Nitric acid. Nitrous oxide or nitric acid. Right? So these acids, when they are mixed with the rainwater, they decrease the pH of the rainwater. Which one? pH. That is decreased. Right? You see, this is the pH values figure. So in this pH scale, it's called pH scale or pH measures. The pH scale measures how acidic an object is, right? How acidic an object is. So the objects that are not very acidic are called basic, right? Objects that are not very acidic, those are basics. These basics. So acidic and neutral and basics. So now you see from the pH scale above, pure water, it has a pH value of 7, right? This one. So this 7 or this value is considered, what is that? Neutral. Neutral, neither acidic or basic. Okay. So the normal, the clean rain has the pH values of between where? 5.6. You see here blue color. 5.6 and 5.5. Sorry, 5.0 to 5.5 or 5.6. So which is slightly acidic. And then we call it as acid rain. This one. So, however, when rain combines with sulfur dioxide or nitrogen oxides, it produced from power plants and automobiles, the rain becomes much more acidic, much more acidic. And typically, the typical acid rain has a pH value of 4 and a decrease in pH values from this 5 to 4, right? 5 to 4 means that the acidity is 10 times greater. 10 times greater. Okay. You see in this picture, up to 7, above it's called acidic, and below 7 to 14 it's called basic. So 7 is neutral. So 7 is neutral. So this is neither acidic or basic, maybe. Okay. So in your examination, they are asking pH scale. So you should write this examples. So pH 0 is battery acidic, and pH 1 is called sulfuric acid, and in pH 2 that is lemon juice and vinegars, and pH 3 orange juice, soda, and pH 4 acid rain. pH 4 means acid rain. So that is 4.2 to 4.4, and acidic lake means 4.5. So it means pH 4 is acidic rain or acid rain, and pH 5 it is they are in bananas and clean rain, and also 5.6 it means 5.6 is clean rain, and healthy lake means 6.5, and 6 in milk is 6.5 to 6.8, and pure water means 7. pH 7 is pure water. And pH 8, that is seawater and eggs. pH 9 in baking soda, and pH 10 in milk of magnesia, and 11 pH 11 is in ammonia, and pH 12 is soapy water, and pH 12 is bleach or bleaching water, and pH 14 is liquid drain cleaner, right? Liquid drain cleaner. So this is the pH values or pH scales and with examples. Okay. So suppose they are asking pH scale. So you should write all these things. Okay. So now we are going to effects of acid rain. So what are the effects of acid rains? So there are many problems and effects caused by acid rains, right? So increased amount of main thing is nitrogen, right? Nitrogen oxides and sulfur oxides in the atmosphere. Those are to contribute to heart and lung problems, including asthma and also bronchitis, right? So the acid rain causes many health issues in animals and human life and also other things. So first we began with plants or agriculture. It's called agriculture or plants. Okay, this one. So effects of plants or agriculture. So the acid rain is very harmful to agriculture and growth of the plants, right? So when acid rain falls on the plants, okay, so it washes away all the nutrients which are required for the growth and survival of plants. So the plants are weak and if continuously they are exposed to acid rain, a long period of time, they may finally dry out or they may be die, right? So the plants are most affected by this acid rain. So now effects of soil. This is the second thing. So inside the soil, there are so many microorganisms is there. So which required a particular pH, right? Particular pH range for the survival. So, but if the pH range falls below normal, what happens? That is, it moves towards acidic. So those are microorganisms, they are not able to survive anymore. So the soil's losses a natural fertility and it also the ability to regain it fertility, which makes it barren over a period of time. So this is the effects of soil. Right. Next one is effect to aquatic system. So especially these aquatic animals. So when acid rain falls down and flow into the rivers and ponds, it affects the aquatic ecosystem as it alters the chemical composition of the water to a form which is actually harmful to the this aquatic ecosystem to survive and causes water pollution also. So at a pH lower than 5, most fishes eggs do not hatch the pH, kill the adult fishes. Okay, so it reduces the alkalinity and increases the acidity of the water, right? So, and also acid rain causes the corrosion of water pipes, so which further results in leaching of um, heavy metals such as iron, lead, and also copper, etc., into the drinking water, right? And last one is monuments or buildings. The monuments are buildings. Acid rain on these buildings, especially those constructed with limestone. Okay. So with limestone and also other soft stones and leading to erosion and the destruction of statues and buildings, right? So acidity can leach heavy metals. What are the heavy metals? Like a mercury, right? Mercury. So mercury out of this soil, it causing toxicity to build up, right? You see some of the pictures here. So this is the first example is Taj Mahal, right? మూతి మీద పెట్టండి. So Taj Mahal is one of the 7 wonders, right? So in the worldwide. So you must know it is turning yellow like this, right? Because this yellow color, because it is largely affected by air pollution and acid rain, right? Acid rain. You see the variation of this picture. It looks like white and it looks like yellow, right? So the city of Agra, what is the reason? What is the reason of this yellow, behind this yellow color? So where is Taj Mahal first of all? So Taj Mahal in Agra city, right? So the city of Agra, it has many industries there, right? Many industries is there. So which emit the oxides of sulfur, oxides of sulfur and nitrogen oxides into the atmosphere. But people continue to use low quality coal and firewood as a domestic fuel and adding to this problem, right? So that's why this white color Taj Mahal is turning yellow because of this sulfur dioxide and sulfur oxide and nitrogen oxides, right? So this is the equation of this Taj Mahal and Statue of Liberty equation, right? And also the Statue of Liberty also, this one. So Statue of Liberty, which is made of which one? Anybody? Copper, okay? Copper. Copper, right? So copper has also been damaged by the cumulative action of acid rain. Cumulative action of acid rain and oxidation for over 30 years. How much? 30 years and days. Therefore, it becoming in which color? Green color, right? Green color. So marble is basically this calcium carbonate, right? Calcium carbonate. So chemical formula of marble, it will be CaCO3. And when acid rain falls on this marble, it can be Taj Mahal, or it can be any other building, or it can be the floor of your houses also. So the acid rain following this reaction with the marble. Marble means calcium carbonate, right? Calcium carbonate. So the formation of calcium sulfates results in the corrosion of these beautiful monuments. So the resulting in the formation of calcium sulfate along with carbon dioxide and water along with carbon dioxide and water. Okay. So this reaction takes place and the marble extracts getting eroded. And the surface starts turning yellow like this. Okay. So because of the deposition of calcium sulfate. So that's why acid rain is particularly harmful for on engine monuments and also buildings. So these are the effects of the acid rains. Now we are going to, what are the effects on public health? These are the, measured to control acids. Those are cleaning of exhaust pipes and smokestacks. And second one is restoring damaged environments. Third one is alternate energy sources and individual, national, or state and international actions and emission control systems. So these are some of the measures to control acid rain. You see here one by one. Okay, right. First one is cleaning up exhaust pipes and smoke stacks. So smokestack, it means chimneys. Not only our household, these are from factories, right? Factory chimneys. And scrubbers should be installed on industry smokestacks. So those are help to remove most pollutants that cause acid rain from being released into the atmosphere. Okay. And so most of the most of the electric power supporting the modern day energy requirements, it comes from combusting fossil fuels such as oil, natural gas, and also coal. So that generated nitrogen oxides and sulfur dioxides. So as the chief contributors to acid rain, what are the reason? Sulfur dioxide and nitrogen oxides. So these are the chief contributors to acid rain. So burning coal largely accounts for sulfur dioxide emissions, while nitrogen oxide emissions are mostly from fossil fuel combustion. So the washing coal, use of coal comprised of low sulfur and use of devices known as this is scrubbers, right? Scrubbers can provide a technical solution to sulfur dioxide emissions. So the scrubbing, this scrubbing also called flue gas. Flue gas sulfurization. It's called FGD. Flue gas desulfurization, okay, FGD. So it typically works to chemically eliminate sulfur dioxide from the gases leaving smokestacks. And it can eliminate up to how much? 95%, right? So 95% of sulfur dioxide gases. So you see, remember, 95% of sulfur dioxide gases can eliminate. And also the power generation. Power generation facilities can also shift to using these fuels that emit much less sulfur dioxide, such as natural gas, instead of burning coal. So these methods are simply called emission reduction strategies. Emission reduction strategies. So similarly, the nitrous oxide emissions from automobile fossil fuel combustions, those are mitigated upon by the use of catalytic converters. I already told previous class. So the catalytic converters are fixed on the exhaust pipe system, that is to reduce nitrogen oxide emission. An improvement of gasoline that combust cleaner is also a strategy for reducing the emissions of nitrogen oxide gases. And second one. Second one, restoring damaged environment. So restoring, how to restore damaged environments? So now you see this picture. So the use of limestone or lime, a process called liming, right? So it is a practice that people can do to repair the damage caused by acid rain to lakes and rivers and also groups. So adding lime into acidic surface water balances this. Okay, water balances the acidity. So it's a process that has extensively been used. For instance, in Sweden, so Sweden, to keep the water pH at optimum, right? So even though the liming is an expensive method and it has to be done repeatedly, right? So furthermore, it only offers a short-term solution at the expense of solving the broader challenges of sulfur dioxide and nitrogen oxide emissions. And also risk to human health also. So nevertheless, it helps to restore and allow the survival of aquatic life forms by improving chronically acidified surface water. So this is the restoring damaged environment with lime. Okay, you see another picture also here. And third one is alternative energy sources. So besides fossil fuels, there is a wide range of alternative energy sources. So that can generate electrical power. So these include wind energy, and geothermal energy, and the solar energy, hydropower, and nuclear power. So the harnessing these energy sources can offer effective electrical power alternatives instead of using fossil fuels. Okay, so the fossil fuel cells and natural gas and also batteries, they can also substitute the use of fossil fuels as cleaner energy sources. So as of today, the all energy sources have environmental and economic cost as well as benefits, right? So the only solution is using sustainable energy that can protect our future. And so, and individual and natural or state and international actions. So the millions of people directly and indirectly contribute sulfur dioxide and nitrogen oxide emissions, right? So the mitigation of this challenge requires individual to be more informed about energy conservation and way of reducing emissions such as turning off lights or electrical appliances when not using them, right? So use public transport and use energy efficient electrical appliances, and also use of hybrid vehicles or electrical vehicles are those with low nitrogen oxide emissions, right? So save electricity and save fossil fuels and save our environment, because electricity is mostly created when we can say the electricity produced with the use of fossil fuels in thermal power plants. So we have electricity will be a reducing dependence on fossil fuels, or we can switch over a alternative sources such as solar energy. So which will help us saving in our environment. Okay. So what are the control system, emission control system or prevention of acid rain? So you see, this is the some of the picture 1990 to 2020, right? So this is India, this second one. This is China, India, Pakistan, South Korea, Thailand, Indonesia, Philippines, North Korea, Japan, Singapore, right? So India is the second place and first place is China. So dangerously highly sulfur dioxide emissions are expected from these cities. Okay. So now today topic is over. Okay. We will take the class tomorrow.